Hi Calculus 1 students. Okay, this is the beginning of a playlist of extra examples that will help you for the midterm. So it's examples that I wish I had the time to do in class, but I couldn't because I had to rush the material in order to finish giving you what you need. So I want to put these examples on YouTube so that you guys have them as study material. Okay, so both section 18 and section 19, I would highly encourage watching these videos. So not mandatory, but I do feel that you're missing out if you're not watching them. So find the values of x at which the tangent line to x plus 3 over x is parallel to the line 2x minus 3y is equal to 1. So this is a problem from the section 3.1. So I'm going to identify the section that I'm in when I do these videos so that you can keep that in mind. Okay? So the reason I want to show this problem is because we haven't done something that is quite similar in class. The idea of finding the values of x for which the tangent line is parallel to another line. So you should remember from high school that two lines are parallel if they have the same slope. Okay, so I'm just going to say here high school. Two lines are parallel if they have the same slope. Okay, so what does it mean? Okay, it means that one, we will find the slope of the tangent line. So slope of tangent line at x, f of x. Remember that this is simply f prime of x. So we need to take the derivative. Then we need to find the slope of the line 2x minus 3y is equal to 1. And this is easy to do. What we're going to do is you're going to solve for y. By solving for y. And finally, you're going to set the two slopes you found in 1 and 2 to be equal to each other and find the values of x. So in other words, like set these two slopes equal and solve for x. All right, so let's do number one. Number one is the easiest, okay? So we want to find what y prime of x is, okay? So y being like this thing. Maybe I should just call it a function, right? So y is equal f of x. That's equal x plus 3 over x. And now, one thing that you should not forget is the preparation step. Okay, so you're going to prepare to take the derivative by bringing the x from the bottom to the top with an exponent of -1. And from there, f prime of x will be equal to just 1 plus 3 times -x to the -2. Okay, so don't forget, the constant doesn't differentiate to 0. Like the constant is the derivative of this guy is going to be 3 times the derivative of x to the -1. So that's why I wrote this. Okay, and especially here, it will be useful to move this at the denominator. So overall, we will get -1 minus 3x squared. So step number 1 is done. Step number 2, okay, so we take that 2x minus 3y equals 1 that we have over here. And what we want to do is to solve for y. So, okay, let's first isolate the 3y. We're going to get like 3y is equal to 2x minus 1, meaning that y is 2/3 of x. minus a third. Okay? So what it means is that this is the slope of the given line. Okay, so it is 2/3. Finally, so again, remember that the setup is that we want f prime of x to be equal to that 2/3. Okay, meaning that you want 1 minus 3 over x squared to be equal to 2/3. And from there, you're obviously solving this like you would solve it in high school. So, which means that the next step is going to be to have like 2/3 x squared, which is equal to 1 minus 2/3. So it's going to be 1/3. And then cross multiplying, you will get that x squared is equal to 9. Oops, 9. Okay, so this is by cross multiplication. And finally, by taking roots, you will have x is equal to plus or negative 3. So in other words, you have two values of x for which the tangent line is parallel to this line. These are x equals negative 3 and x equals 3. Hopefully this was helpful. See you in the next video.